So before looking at the next example, I want to remind you about the power to a power rule. What this is if you have some power, like, I don't know, maybe 2 squared, and you then raise that to a power, say we raise that whole thing to the 3rd power, what this is really saying is we have 2 squared 3 times. We have 3 of them. That's what this exponent means. Well, now that you can see this is just 3 of these multiplications, the product of a power rule tells us we can just add the exponents. 2 plus 2 plus 2 is 6. So note the shortcut there was just to multiply those powers. So the power to a power rule tells us that when we have a power raised to a power, we just multiply those powers together. Let's see how that works on our algebra. If we take a look at number 9 here, 27 and 3, well, those are not the same base. So we do have to go back to our table. 27, well, that's the same thing as 3 cubed. But it's not just a simple numerical substitution anymore. 27 is 3 cubed, but we still have that 2x plus 6 lying around. So we have 3 cubed to the 2x plus 6 power. We didn't change anything on the right, so we'll leave that alone. So we have common bases, but there's a bit of extra work to do here. That's a distributive property. We need to multiply that 3 times the original exponent, 2x plus 6, because it is a power raised to a power. 3 cubed, well, that 3 is my inside power. The 2x plus 6 is my outside power. The algebra here still isn't too difficult. There's an extra distributive property lying around, but the concept can be a bit tricky. Power to a power, again, we're just multiplying those 2 powers. In order to multiply one number by a binomial, that's distributive property. So 3 times 2x, that's a 6x. 3 times 6 is 18. Whole thing equals 2x. So this winds up having an x on both sides. A couple of different ways you can go about this. I'm going to go ahead and stick with the pick on the little guy mantra. Subtracting 2x from both sides will get rid of all my x's from the right. In order to do that, I also need to subtract 18 from both sides. 6x, take away 2x is a 4x. On the right-hand side, we get negative 18. And then dividing both sides by 4 will get us that x is, now 18 over 4, that can be reduced since they're both even numbers. So as a fraction, that's the same as 9 halves. Or as a decimal, you could say negative 4.5. Either one of those would be acceptable. Looking at another example here, note that 16 is the same thing as 4 squared. You might not need the table in order to look that one up. 16 is the same thing as 4 squared. So we will wind up with another power to a power rule. Because again, we have that 2 there from the 4 squared, along with that y minus 3 from the original problem. So there will be a distributive property that shows up in the algebra here. So distributing that 2, not too bad. 2 times y, well, that's just 2y. 2 times negative 3 is a negative 6. So now we have a variable on both sides. Picking on the little guy is my preferred method here. So subtracting a y from both sides. Then we'll also have to add a 6 to both sides. 2 plus 6 is 8. 2y, take away a y, well, that's just y. So this one winds up not too bad. We don't have to do any division at the end there. So that's how we would handle something with a power to a power rule. I do want to take a look at some that are a bit more challenging, but make sure you understand these two before moving on. That power to a power rule, where you have an exponent and then you get another exponent, that does step the difficulty up just a bit. So let me know how you're feeling with these before you move on to the next one, and I'll see you soon.